Good afternoon, good evening, wherever you are. My name is Arun Gupta. I'm the Vice President and General Manager for Open Ecosystem Team at Intel. You can find all about us at open.intel.com. We also have a wonderful podcast that you can look at open.intel.com/podcast. Today, I'm very excited and happy to be here with Frank. Hey, Frank.
Hey, Rin, how you doing?
Very good. How are you doing?
Yeah, I'm doing pretty good as well. Thanks for inviting me onto the show, onto this webinar. Looking forward to getting it underway.
Absolutely. Do you want to introduce yourself?
Sure, absolutely. So, my name is Frank. I've been at Zilliz for about coming up on two and a half years. And primarily at Zilliz, I actually do a slew of different things. Sort of a bit of a jack of all trades. I'll come out, give some talks like these, talk to a lot of our users, prospects, some of our customers, and I also train embedding models as well. And for a period of time, I was also running the dishwasher at night. So really a little bit of everything. And that's just the way that startups are. I'll sort of intro, Arun, if it's okay with you, I'll intro Zilliz as a company and also Milvus, the project as well, just so the audience has a bit of a...
Yeah, yes, let's jump into it. So
Oh,
we are today,
yeah, okay. No, that's perfect.
yeah, today we are talking about Milvus, high performance vector search at billion scale. So let's talk about it.
Yeah, absolutely. I'm going to sort of try to divide this up into maybe 2 or 3 different sections. And I think for the first one, I just want to introduce Milvus, give folks a good high level understanding for what a vector database is, why is vector search important, and then after that, I want to talk a little bit more on the application side, right? Why does a vector database matter to you, even if you're not building, let's say, applications that leverage large language models or applications that leverage retrieval-augmented generation? Why should you still care about a vector database, right? Why are vector databases going to be ubiquitous in 2025 or 2026? And just a quick introduction myself. My name is Frank. I'm director of operations, head of AI and ML. I do a number of different things here. And really, if you look at Zilliz as a company, we've been around since 2017, and we are the key maintainer of a number of open source projects. And in particular, we are the maintainer of Milvus. Milvus is an open source vector database that is, it's freely available on GitHub. You can go there, download the code, look at it, download it, play around with it on your own computer. I'll show you guys how to do that a little bit later in this webinar when we go to a Jupyter notebook. But beyond that, we also have a number of other open source projects as well. And then we also have Zilliz Cloud, right? Zilliz Cloud is based on Milvus, and it is the managed vector database service that we provide as well. And I'll talk a little bit more about all of these later on in the future. Now, if you're really curious, there's these 2 names flying around, Zilliz, Milvus. The analogy that I like to use is that what Databricks is to Spark, Zilliz is to Milvus. So Milvus was created at Zilliz in 2018. It is currently the world's most widely adopted vector database, most starred vector database on GitHub. It's got over 25,000 stars now, coming up on 26,000. And again, we've been around for a while. Zilliz has been around since 2017, and Milvus has been around since 2018.
So essentially, developers can go to Milvus GitHub repo. They can fork it, clone it, download it, and then play around with it.
Yep.
But if they don't want to do that, or they want a managed version, let's say they have tried around with it, the open source version, and they say, okay, I'm ready to go production, and they want somebody who can manage it for them, that's when they go to Zilliz.
Yep, exactly. And I'll have a couple of slides at the very end about this, talking about the different versions of Milvus that you can download and use, whether you're a data scientist all the way to a team of DevOps engineers, or if you want to use a managed service, as you mentioned, Arun, right? If you want to use managed Milvus, right, you can go ahead and go on Zilliz Cloud. And I'll talk about that a little bit more in a little bit more detail towards the end of this webinar, towards the end of this presentation.
Okay.
But
and what are the other projects like R2, 2E? What are these other projects?
Yeah. These you can think of them as part of the broader vector database ecosystem, is what I like to refer to it as. And R2 is a management UI for Milvus, but beyond Milvus is also an open source management UI, GUI for vector data. Tohi is meant to turn your unstructured data into vector embeddings so that you can store them inside of Milvus. You can create these things called pipelines in Tohi. And that'll actually allow you to take a variety of different sources of data, different modalities of data, and get your data inserted into Milvus. GPT Cache, actually, that's probably, I was surprised by how popular GPT Cache got. It was meant to be sort of a fun side project that we created, and that is what we like to call a semantic cache. Semantic cache, you can essentially think of it as, I don't want to be hitting the OpenAI endpoint all the time. Sometimes I want to just say, if I have two prompts that are very similar to each other, I want to take the existing result, I want to take the existing output of OpenAI or whatever other large language model that I have. I want to return that back to the user. I would have loved to give a demo of GPT Cache in this session, but maybe next time, Arun. But and then VDB Benchmark is a benchmark tool for vector databases, and Nowhere is the core vector indexing engine or vector search and querying engine inside of Milvus. I know that was quite a bit. That was actually quite a bit of information there. So, if there are any questions, feel free to just stop.
Yeah, so I mean, you said Milvus and all of these are open source projects.
Yep.
And is Milvus a standalone project? Does it belong to a foundation? What's sort of the governance model over there?
Great question. Yeah, Milvus is actually a part of the Linux Foundation, specifically the LF AI Data Foundation. And it actually joined in 2019 and became a graduate project, I think, in 2020. I might be getting my dates mixed up. Is that 2020 or 2021? So it's been in the Linux Foundation for a while. There's actually a sort of a core group of maintainers, and big part of that core group is actually from Zilliz. So if you actually look at the number of active maintainers of the Milvus project, I would say probably 80% of the of the contributors, maybe even 85% of the contributors are from Zilliz. So we still put a lot of our weight behind Milvus, but we want to have a really key. We're an open source company first and foremost, and one of the we always will be. We have been and we always will be. And one of the key things that we wanted to adopt when it came to Milvus is a really, really open sort of governance model, as you mentioned, Arun, and giving people the capability to feel confident in a project like Milvus with the backing of a foundation like Linux Foundation. So, yeah, great question.
Beautiful. Let's keep going.
All right. So, okay, so I know there's for this webinar, there's probably folks from different, I would say, different parts of the vector search or the vector database spectrum. So, for folks who aren't too familiar with vector search, I want to do a quick recap, right? What is vector search important? Why is vector search important? Excuse me. Why should you care about vector databases? What do vector databases do, and why should they be a part of your stack? And then next, I'm going to go into Milvus, right? I'm going to talk about why Milvus is one of the best vector databases out there. What are the key features of Milvus that differentiate us from a lot of the other vector databases or vector search solutions? And then in the last section, I want to talk a little bit about some of the applications. I say the future of vector databases here, but I'm going to talk more about the future relative to what we have seen in the past, not just couple of years, not just 2023, but in the past several years as well, starting from 2018, right? Where are vector databases going? And I think this will probably interest quite a few folks.
Yeah, and if I look at the chat here, a LinkedIn user is saying howdy back to you. Mm-hmm. And there is Sankal who's putting the name in there, Branimir Angelo. I don't know if that's a name or that's a comment. But hello. We'll keep rolling and keep bringing your questions.
All right. Yeah, hit me with questions anytime you guys want, and I'd be happy to answer them at any moment. And it's always nice to be able to have a back and forth with the audience as well. So please just interrupt me at any moment in time if there's any questions in the chat. But I'm gonna talk about vector search and vector databases more broadly first, right? And if we look at vector search, if we look at vector data, what it is meant to represent is unstructured data. And unstructured data is absolutely everywhere, right? If you look at a report by IDC, and I think by other vendors as well, I think maybe Gartner, don't quote me on that. By 2025, 2026, 80% of our data is going to be unstructured data. And that is a lot. That is a lot. Now, if you look at computers, starting from ENAC back in the 60s, one of the key things that computers were meant to do is help you store data and generate insights over that data. Actually, I would argue for better or for worse, that if you really distill everything down, that's the only thing that computers are meant to do: store data and help you generate insights over that data. And traditionally, that's been done in a tabular model, right? We sort of, as humans and computers, we meet halfway and we say, okay, we can store this data in table-based format. We query it with SQL, and then that becomes a way for us to interface with the computer. A lot of that, if you look at SQL, though, it is structured data that has a predefined data model, data that you can fit into a table. But I think in the past 20 or 30 years, you've slowly seen a shift from structured data to unstructured data. Right now, unstructured data is extremely important. You have things like Spark that can help you, these big data lakes that can help you ingest vast quantities of data and help you generate insights over them. And really, if you look at how people process unstructured data today, whether it be through clustering, through classification, a lot of that is done with deep learning.
If I take a pause there for a second, and I'm thinking about contextualizing that information for myself,
Totally.
like we take pictures, we send text messages, and the text messages are scattered all over the place, like WhatsApp or a text message or iMessage or whatever, right?
Yep.
Or Signal. We send emails. All of that, asking to fit all of that into a SQL table is not the right model, because we are just jamming it in, putting like a square peg in a round hole. So in that sense, the number of 80%, it seems like a conservative number to me, because think about the amount of data that exists around us is far bigger probably than 80%. Maybe 90% data is unstructured.
Probably, yeah. And perhaps perhaps for a lot of that data, we just don't capture it, right? Because, we don't have a great way to process it.
Exactly.
If we
that's
do,
wonderful.
yeah, not only, we today, if we do, that number is probably going to go up. And I would argue eventually maybe we see 95, maybe even 99% of the data we capture unstructured.
And the crux of that is that unstructured data around us is what creates our context.
Absolutely.
Okay.
Absolutely. Yeah, no, exactly. I think you hit the nail right on the head there. So there's having vast quantities of unstructured data and putting that unstructured data into, a vector database for search. That is, eventually a vector database is going to be more than just approximate nearest neighbor search. And I'll get to it a little bit more in this slide as well. Today, you see vector databases plus large language models in what's called retrieval-augmented generation. That is the most common way of building applications that leverage vector databases, but it's only one of the many ways, right? It is the most popular way today. I really have to admit, a lot of our users of both Milvus and Zilliz Cloud use it in conjunction with a large language model. And that's great. That's great for that first use case that you see there for text. But as we move into, you see large language models are becoming large multimodal models, right? So LLMs are becoming LMMs. They're going to be able to ingest and generate images, audio, potentially even videos, short GIFs as well. They're going to be able to analyze different types of data, IMU data, time series data. And if you think about it from this perspective, text alone is no longer enough. You need a vector database that's purpose-built to handle it's vector first, basically, right? Really, that's what we've set out to do since the very beginning.
Right. So we're talking about LLMM, large language multi-model.
Yeah, exactly. Yeah. You're going to have text is going to be there's this paper called ImageBind released several months ago by Meta. And I think these days we're moving towards a modality where it's going to be text bind. Different modalities of data are going to be bound to text. Text is going to be the central modality. And then you'll have images that you can map to text. So for example, images, let's say of a landscape image or something like that, you use text to describe it. And same thing with, let's say, IMU data. Same thing with molecular structures. You can use text to describe that data. That's where we're going, and that's why that's why in a lot of our users, that's the way that they see things as well, and that's the direction that we're going to be going in the future. So very, very high level, but I'll definitely get into, for folks who like to be a little bit more hands-on, I'll get into some code specifically. I'll get into some code, an automated customer support bot a little bit later on. But I'm gonna try to breeze through these slides so that there's some time for a back and forth in the middle as well, sort of podcast style. But really, vectors, they unlock the potential of unstructured data. If you have your knowledge base could be a variety of different modalities. There's images, video, audio, and text here. Text today being the most common one. You run these through deep learning. It says deep learning models here, but really at the end of the day, these are embedding models, right? These are models that turn your input data. They will ingest your input data, run them through a neural network, and this neural network, typically these days, it has some form of attention, self-attention. It's either a transformer model or a hybrid model, and then these will be turned into vectors. And these vectors are generally, let's say, anywhere between 64 dimensional, 96 dimensional, and I've seen it go all the way up to 10,000, over 10,000 dimensions. And that vector ends up being a great representation of your input data. And I think I have a slide coming up here that talks about why vectors are so important. This is from the ImageBind paper. There's a link down there as well. And if you look at it, right, not only are we able to bind audio to images. So if I have audio of a crackle of fire, I turn that using ImageBind into an embedding. And then in my database, I've stored a bunch of images and I turn those images into embeddings. Now, all of a sudden, I have ways of being able to match audio and images. I can do the same thing with text, right? I have these depth maps, and then there's text on the right-hand side. And then I can find the most relevant piece of text given some depth images. And this is really incredible, right? But I think it just goes to show that today I think a lot of, I want to draw an analogy here, right? I think in the 80s, the Netscape Navigator days, before I was born, the days of, or around that time that I was born, there were, you had these browsers, and these browsers, they gave a lot of people an interface to the web, because in the 90s, I think, still a lot of computers, they were primarily only text-based. Once you had these browsers, once you had these broader interfaces, all of a sudden, you started seeing more images. You started seeing like these dancing GIFs pop up on these web pages, and then these web pages slowly became more and more complex. They incorporated more and more modalities of data. Now we have things like YouTube, Instagram, short videos, long videos. You can play audio. You can, of course, you have text on these web pages as well, but you also have a lot of other embedded content there too. And the same thing is going to happen with large language models, right? Just as the advent of the internet really reinvented the way that we interact with computers, so have large language models. Now today, it's primarily text-based, but in the future, as I mentioned a little bit earlier, it's going to be multimodal. You're going to interface with a variety of different modalities of data, not just text, right? And that is why this is so important for us moving forward. Yes, RAG is great, and I think there's a lot of value to be had in pure text retrieval augmented generation. And I'll talk about that a little bit more later on in this session as well. But if we really look into the future, what is really, where are we going? This is where we're going. We need a way to be able to match all of these modalities together, to be able to do retrieval augmentation over images, over videos, and over text. And that's what's really going to give us the most value out of our large language multimodal models, or large multimodal models, in addition to how we interact with them using a computer, right? So moving forward here real quick, and I think, and this is talking more about retrieval-augmented generation. This is, I would say, the first killer application for a lot of vector databases or for a lot of vector stores. You have, a large language model, and you have a question, or you have some prompt. That prompt is first going to come in to the vector store. The vector database, in this case, Milvus or Zilliz, is going to search for the most relevant documents inside of it. That's going to then go into an LLM, and then the LLM, along with the original question and the context from the vector database, is going to generate an answer for you, right? This is retrieval augmented generation, and a lot of folks that we see today are using vector databases, as I mentioned, in conjunction with LLMs to do something like this.
So if we take a pause here,
sure thing. Yeah.
Somebody makes a question to LLM. Instead of going directly to the LLM, you put the vector data in between,
Exactly.
You retrieve the context and you
Right.
augment it, and then that's the data that gets sent to the LLM. So the chances of hallucination are less. But in the previous slide that you were talking about, as we are going forward,
Yes.
for a large language multimodal data,
Yes.
this entire information needs to be stored in a vector database. So RAG is just one application of it, but the
Exactly.
entirety of this information needs to sit in a vector database, essentially.
Exactly. Exactly. All of our different forms of data will need to sit in the vector database, and eventually I'll be able to retrieve, let's say, images or audio snippets, and those will all go into the large language model.
Got it.
Exactly. Exactly. Right. That is sort of, you can think of it as retrieval augmented generation on steroids, and it's why it's so important that we have a database, a vector database that is where vectors are first class citizens, right? They are not, quote unquote, text is not the primary modality inside of a vector database. You have to have a way of being able to represent your data in a way that computers can easily process. And that's what a vector database is all about. That's what real vector databases are for at the end of the day. So even though retrieval augmented generation is the primary way to go, there's a lot of other applications beyond that as well that leverage all of these awesome modalities, all of these awesome ways that we can represent our data, and all the ways that we interact as humans with the rest of the world. So for example, you have things like image similarity search, you have video similarity, any type of similarity search, you have recommendation, you have recommender systems, you have molecular search, you have AI-powered drug discovery, fraud detection, anomaly detection. These are just some of the multiple sort of forms of use cases that you have when it comes to vector databases, and that's why things are so exciting.
And this is only possible because of the semantic search capability
Precisely.
that the vector database allows us to do that.
Precisely.
Because the data itself is stored in a semantic manner.
Precisely.
So there's a question here.
Go ahead.
So let's talk about it. What specific changes do you see being made to the underlying legacy content assets? For example, metadata augmentation, cleanups, etc. What legacy activities are no longer relevant?
Yeah, that is a great question. I don't necessarily want to say, like, at the end of the day, I don't think vector databases are there to remove or there to replace traditional, let's say, relational databases or object databases or object stores or document databases, right? I think at the end of the day, if you look to build out an application in the early stage, sure, you can select just a vector database, and you can have in a vector database, you can have metadata. You can have metadata associated with each vector, and that metadata can then be used. You can use that metadata search in a way that you typically use in RDBMS. I think moving forward, though, if you really talk about a big application, relational data, tabular data, object data, document data, and vector data, these are so different that it's important to have a purpose-built databases for different types of data. And I know that's probably, if you're a developer, it's probably not the answer you're looking for. You need multiple databases. But I think early on, yes, you can just start with one database, right? I'm not saying you have to have all, but you start with one database, a database that has both, regular tabular search as well as vector search. And then later on, it's important to move these separately, because at the end of the day, it's very, very hard, I would say nigh impossible, to have a one-size-fits-all architecture for traditional structured data as well as unstructured data, right? I don't necessarily think that vector databases are here to replace quote-unquote legacy databases. I think rather, if we move forward, they're going to work hand in hand to be able to give you the best and most performant capabilities for your application that you need. Now, I'll talk a little bit more about performance and why performance is important for your vector database moving forward as well.
Yeah, I mean, the way I think about this is there was not a need for vector databases up until now, because the LLMs were not there, the multimodality was not a big deal. But more recently, this is a new sort of data need that we have, that is proliferating all around us.
Exactly.
And now being able to tap into that. So I know it's the most annoying answer. It depends. But really, you need like a relational database, a document database, and now a vector database, and then together combining that is where your information is coming from.
Exactly, right. And I would say, if you're a developer, like, don't fret. You don't need all of these databases. You can start with, let's say, just a vector data. You can start with just Milvus, because there's a lot of things that you can do in Milvus. Milvus has, let's say, for example, JSON support. You can store documents. You can store JSON blobs inside of Milvus. You can use it as a traditional object database or relational database, but that's not what it was built to do.
Right.
I want to be
So
very.
I think you're kind of answering sort of the next question as well. What are the advantages of a dedicated vector database engine compared to vector database capabilities integrated with a relational database?
Great question.
Like I've seen MongoDB now has vector search capabilities. Cassandra now has search capabilities.
Yeah.
So these are traditional document databases, because when you are leveraging in an enterprise, you already have like a MongoDB or a Cassandra sitting for many years. And now you say, oh, I need to bring new engine as opposed to MongoDB
Great
already
question.
has vector database. So I
Great
think
question.
help me
Yeah.
compare and contrast those things.
That's actually a great point. And I want to say this, which is, if you look at Elasticsearch, or if you look at MongoDB or Cassandra, and they've built vector search on top of their existing stack, that's amazing. And I think it's really, really good that we're seeing more people adopt vector search. In many ways, it validates what we're doing, right? It validates what we've been doing for the past 5-6 years. But at the end of the day, vector data is so different. And, for example, if you look at a traditional relational database, typically these use, I think it's B trees as the underlying data structure. If you look at MongoDB, for example, I think they use LM trees. Again, don't quote me on that. I'm not really a data structure guy, more on the AI/ML side of things. And in a vector database, you don't use any of those types of indexes, right? Actually, currently the most performant indexes in a vector database are not even tree-based. Tree-based indexes actually sort of perform somewhere in the middle. I'm sure there's work that's being done to improve the performance of tree-based vector search indexes, but currently graph-based indexes are the most performant. And just by that alone, if you think about just that alone, you need a different, if you want to extract the most performance, if you want to get the most, not just the most performance, but the best performance at the least cost, that's why you need a purpose-built vector database. And again, for the viewer who just made that comment, I'm sorry I didn't catch your name. For the viewer who just made that comment, or who just asked that question, that is a great question, because like I said, I think if you're an early stage developer, you can just use Milvus, or you can just use Zilliz Cloud to do everything, right? It will do tabular search for you. It will do object or document search for you. And it will do vector search for you. But as you move forward, again, I think it makes sense to split out those different types of data into different databases once you start to scale, once you start to grow. And then
and that's how I see it. If you think about the microservice
Exactly.
architecture, you start building your application, small, it grows big, and then you peel off a functionality that goes to a separate application, and then you peel off another part of the application. And that's the way I'm looking at it here. So maybe it's okay to start with MongoDB or whatever your traditional databases, if they have vector capabilities, but now you're looking to scale, and now you're looking to go to billions and trillions of, whatever vectors over there. Go for it. And then that's sort of the scalability when you're looking at a dedicated vector database.
Exactly.
Right.
No,
Okay.
you're absolutely right. Yeah,
Let's keep going.
right. And I think that was a great question, by the way. So I appreciate the viewer who asked that. Now that we've talked a little bit about, again, for some of the audience who's a little bit less familiar with vector search, with vector databases, why vector databases matter, I want to talk about Milvus, and I want to talk about what makes Milvus unique from a database perspective. Why is Milvus, how is Milvus different from a lot of the other vector databases out there, and why should you care about what we're building? And if you really look at some of the key features of Milvus. First of all, Milvus is a distributed system. Like I'm just going to come out and just say very, 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 very quickly, it is a distributed system. But why do you need a distributed database? It's simply because once you get to, let's say, beyond 50 million vectors or beyond 100 million vectors, and you want to continue to scale vertically, yeah, you can do that, but it's hard, right? The costs become astronomical once I go beyond 64 gigabytes of RAM. If I need 128 or 256 gigabytes of RAM and a large disk as well in a single machine, yeah, I can do that, but it is not the most ideal way to do things. And also moving forward, if you want improved throughput, or you want improved query speeds, you want to lower your latency, the only way to do it is to scale horizontally by distributing the index across different machines so that you can get better throughput, so that you can get better insertion speeds, right? Why you need a distributed system is simply because it is so applicable to a variety of different applications. If you have write-heavy workloads, if you have read-heavy workloads, you need a distributed system so that you can handle all those different types of workloads, so that you can make sure that, hey, at the end of the day, I'm getting the performance that I need for my application, right? Yes, it does make Milvus a little bit harder to use at the very beginning, but we have ways of getting around that. We have, for example, the Zilliz Cloud free tier, as well as Milvus Lite, which I'll get into a little bit later on in about 15, 20 minutes when I get into a little bit of the code, talking a little bit about an application, that automated customer support bot. In addition, we also have real-time read and write. And this architecture, there should be an architecture diagram later on in these slides, but it enables you to insert quickly. That the use of that nowhere engine actually gives us really, really high performance, gives Milvus really, really high performance, and you have data. You can ensure that your data is, well, depending on your consistency level, it's always going to be up to date, right? Based on a lot of your data needs, based on your application needs, we also have a variety of different indexing strategies, and that will help you enhance your query performance. So I'll give you a quick example, right? For folks who are very, very familiar with vector search, if you want very, very low latency and you want really high throughput, you can use something like HNSW, right? And high recall as well. You can use something like HNSW or some other graph-based in-memory index. And what that'll give you is it'll give you really, really good performance at the expense of more quote unquote storage. And in this instance, more in-memory storage. If you don't need that kind of recall, but you still want things to be very quick, you can use something like IVFPQ. IVFPQ not only does quantization, but it actually will bin it'll sort of split the vector search hyperplane into multiple, it'll split your hyperplane into multiple sort of cells, Voronoi cells, and then you only need to search over a subset of those cells. And again, those vectors are quantized. That's why you get really, really good performance at the cost of recall. All right, but you don't need to use that much memory. So there's a lot of indexing strategies that you can use to enhance query performance and tailor Milvus towards your application. And then on top of that, we have batch processing, right? So this is really important. I think this is one of the things that's often left out in vector databases, which is you need a way to be able to batch import and batch query, simply because if you look at modern machine learning models, again, I'm going to go back a couple of slides. If you look at modern deep learning models, if you look at modern machine learning models, these are typically done, especially if you have a GPU to perform inference. Batch inference is typically done so that you can leverage a lot of the streaming multiprocessors on a GPU or even on an FPGA, depending on what type of computing platform you're using, right? Really, really important to have batch inserts, bulk inserts. And if you look at this particular slide here, I actually borrowed from one of our really, really awesome engineers, principal engineers here at Zilliz. If you look at Milvus 1.0 to 2.0, Milvus 1.0 is where a lot of vector databases are today, right? It is a single node, single instance vector database. It's great for getting started. And again, if all you want is a single node vector database, if all you need is single node vector search, we have that capability as well today in Milvus. Show that a little bit more in a later slide here. But this is the architecture of Milvus 1.0. You have proxy, you have your storage layer, your indexing, querying. It all happens in a single node. And it's communicating with object store at the end of the day as well. You have insertions and searches that come into the single node, and you go from there. But as you move forward, as you move into a distributed system, the first thing that you need to do is, make all of these, you have to divide all these services into pods. Arun, you were talking a little bit earlier about distributed computing. You're talking about Kubernetes and the capability of using individual pods, breaking out, right, all of these things, individual pods, sort of like pipelining in computer architecture. Instead of doing everything in a single CPU cycle, now you've split everything into multiple CPU cycles. You run all the cycles much quicker, and you can do a lot of things in parallel. And it's the same concept here. You
I think
split
the
out.
other important part here to understand is the needs for a data versus index versus query are very different. Data is very disk bound. Query is like processing bound, and also in that sense, index is more memory bound. So now you can once you have decentralized it, you can actually put them on the node and bump up the CPU capacity or the memory capacity or the disk capacity. That
Precisely.
makes it a lot more amenable and a lot more efficient for you.
Precisely, right? And if you have, for example, I was talking a little bit earlier about supporting different workloads, and Arun, you again really just hit the nail on the head, which is if you have a write-heavy workload, you probably want to scale up your data nodes, and by extension your index nodes as well, to be able to support consistent, constant ingestion of data, so that you can have those data nodes. And I'm gonna fast forward here real quick. You can have those data nodes continually write to object storage. Now, if you have a really read heavy, or if you have a query heavy workload, you probably just want to scale up your query cluster so you can have a lot of those query nodes continue to operate. You can have a lot of those query nodes really operate at full capacity as vector data as you're querying your vector database. If we look at all of these different components inside of Milvus 2.0, you need a way to be able to have all of them communicate with each other, have all of them synchronize with each other, basically. If you have different pieces of data coming in, so for example, new data needs to be sent not just to the data nodes, but also to the query nodes, because you have this concept of segments, these growing segments inside of your query nodes. Until those segments become sealed and there's an index over those segments, you have to query over them so that you're not losing a lot of that data that you've inserted initially. As we move forward, you have these insertions and searches. They go into what we call the access layer first, which is composed of multiple proxies. Searches will actually go directly to the query node, and actually insertions, the write path, those vectors will go into the log broker. And in this case, you can either select Kafka or Pulsar. They will then go into data nodes, and then those will get written into the write-head log inside of object storage. The index nodes will pull that data from object storage, and then once it's built the index, it'll actually write it back into S3. Now, at the same time, as I mentioned a little bit earlier, query nodes also need newly inserted data because they're the concept of growing segments. And that is why you have this type of architecture. That's why you have these searches and these insertions going like that. One last thing that I forgot to mention, as that index gets built, the query nodes will actually read them from object store, from S3. So this is what gives you the really, really solid performance, the really incredible architecture that from Milvus 1.0, except expanded, so that you have really many, many different ways of being able to, you can support many, many different workloads, right? You can support.
So it is truly like a distributed architecture, where
Absolutely.
they're loosely coupled, pulling data from each other and collaborating and coordinating with each other to make this happen. I do have a question from a user here. I
Go
would
ahead.
say, in the context of Milvus, how is vector persistence managed during operations such as data upgrades and refresh cycles? Furthermore, does Milvus provide a mechanism to retrieve or roll back to a previous state of a vector such operations?
Great question. So that is a great question. In Milvus 2.0, because, well, by extension, Milvus 1.0 as well, but it's a little bit different. I don't want to get too much into the weeds here. Because everything lives in object store, so as things are getting written into data nodes, as the data comes in, it'll actually write everything. If you look at the write path, the green arrows here, everything will eventually go into S3. Because of that, because we use S3 as really the underlying storage engine, cloud-based storage engine, what happens is you can actually just shut down your Milvus cluster, spin up another Milvus cluster, with an upgrade version. Let's say you want to upgrade from Milvus 2.2 to Milvus 2.3. You shut down your Milvus 2.2 cluster, and simultaneously you bring up a Milvus 2.3 cluster. And all you need to do is point that Milvus 2.3 cluster to the S3 bucket that you've been using for Milvus 2.2, and all of a sudden you've got an upgraded cluster, right? That's the beauty of separation of storage and compute. And I think if I move forward here, that's the first thing that you'll see is we have separation of storage and compute. Not only does it provide better scalability and isolation, but you can also manage your data much easier, right? You have all this data that just lives in S3, and with that data, you can then do the migration as you see fit. You can even migrate between two Milvus clusters and two different colos simply by just copying over the data from one colo to another colo and then spinning up another cluster in that other colo, right? It's very, very easy to do. That's a great question, though, and it really ties in exactly with what I want to continue to talk about, which is, this Kubernetes-based, microservices-based architecture. Yes, it does make things more complicated, but that is how we're able to make Milvus so easy to tailor to different types of applications, easy to customize to your specific needs, and also give it the capability to have really, really solid performance, right?
And is that what ties to the fact that Milvus is also called as a cloud native vector database?
Exactly. Yes. Yeah. So when we say, I think, the word cloud native is really thrown around in different ways. Sometimes if you have an application that's just based on Kubernetes or it's a microservices application, then people will say, oh, it's cloud-based because I can use EKS, right? But when we say it's cloud-based, it really every aspect of it is cloud-based. And, starting from, for example, the access layer, the proxies, they will, in the coordinator layer, they'll use etcd to communicate amongst themselves, and the reason why you need etcd, and the capability of being able to use object store using S3. If you're running it locally, you can use min.io, and min.io will actually sort of give you an S3-like endpoint. Also using Kafka or Pulsar as sort of a cloud-native technology, a cloud-native log broker as well. Every aspect of Milvus is meant to be run in the cloud. It's not just something that you say, okay, I'm going to split out my existing monolith application to microservices and then to cloud-native application, right? That's not the case. In this instance, we actually leverage many different components of the cloud, of AWS, of GCP, of Azure.
It's not an afterthought. It's from the ground up. Design is like that to be cloud native.
Precisely. And Milvus, Zilliz as a company, we were one of the earliest ones to do that. We were one of the earliest ones to start the evolution to Milvus 2.0, and we sort of completed it back in 2021. And that's why like if you look at a lot of our users, sure, there's a lot of developers on there, but there's also a lot of really, really, there's a lot of organizations that need things like highly available database. They need these really key features like backup and restore, role-based access control. And that, by doing this evolution early, we have the capability of not just supporting billions of vectors at really good performance, but having a lot of those key traditional distributed database features inside a vector database. I would argue that we're still the only ones to have that capability.
Wonderful. Okay, we got about 15 more minutes to go.
Yeah, so I'm gonna try to wrap this up in 7 minutes. I'll try to be very quick here. I want to get to a quick demo.
Yeah.
In this demo, again, I've been talking about Milvus 1.0 to 2.0, right? I've been sort of talking about our story, but this demo is going to be more focused from a developer perspective. Oh, okay, and I have another set of bullet points here. What this architecture gives you, it gives you scalability, it gives you a lot of resource optimization and that kind of stuff as well. I'm not going to talk about this too much. I will go over it very briefly. In Milvus, you have this concept of segments. And inside of your message queue, inside of your log broker, you have different channels, and those channels will actually correspond to different segments. Now, as segments grow, they need to be in both the query nodes as well as the data nodes. And because brute force search is done over these growing segments, by default, you can also build an index over them if you'd like. That gives you maximum data freshness, right? So that if you insert something, it's going to be available immediately in your vector search. I'm not going to go too much into there's a lot of details in here that I don't want to go too much over into the architecture here, but that is just a very, very high level understanding of how you can, high level explanation for what segments are, right? There's segments inside of traditional databases as well. And again, like I said, we're really bringing that traditional database model to vector search. It's one of the really, really important things that the entire vertical really is going to be doing in the near future, and that's what's so important. There's also the idea of compaction, where you can take multiple small segments as you delete from your vector database. In Milvus, you actually implement a soft delete. As enough deletes for segments happen, what will happen is the index node will then the index cluster will actually retrieve small segments from S3, compact them into a single larger segment, write them back into S3, and then you can delete the old segments as well. So really there's a lot of distributed computing, a lot of locks that's happening across all of this data. I'm not going to go over this one too much. And this is a high-level Milvus architecture, one of my favorite diagrams to go through. You see, not only do you have separation of storage and compute, object storage down there in the worker nodes in the second to last layer, but you also have separation of different types of compute as well. And that is extremely important if you want to support a variety of different applications. If you want to support different, not just vector search workloads, but also filtered search workloads. If you want to be able to support pure, let's say, object search or document search, you can, again, as I mentioned, you can start building your application directly using Milvus. You don't have to leverage a relational database or MongoDB. You can just start building from Milvus. Everything that you need is available in Milvus. You can create a collection that has only tabular data, doesn't have any vector data, or you can create a collection that is only JSON data, doesn't have any vector data, and then start integrating that vector data later on into your application. It's one of the things I love about Milvus. And then I'll take a couple, 2 or 3 more minutes because I know we're short on time, and I want to sort of get to this Jupyter notebook that I have here. I want to talk about the future, not just of vector search, but I want to talk about the future of vector databases in general. And really, the possibilities are endless. Now, OSS Chat up in the top left-hand corner, it's actually another open source project that we have, which I forgot to add into that earlier slide. OSS Chat is a way for you to be able to chat with open source software. And the way that we built it, it's one of the early sort of retrieval-augmented generation systems out there. It's been out there for a while. And essentially what you do is it will search the vector database first for relevant open source documentation. And then you can ask questions over that documentation. So what ChatGPT or what Llama 2 or what Mistral, what these large language models don't have already, you inject that information into the LLM, and then you can answer questions of it. Right? You also have things like image similarity search in the lower left-hand corner, and also one of my favorite applications, molecular search and AI drug discovery. All of this is available on milvus.io. You can go just take a look at some of the demos that we have on there, and it just goes to show you the power of vector search and some of the really interesting things that you can do with vector search. So moving forward, right? Like, are we done? And again, this is another slide from one of our engineers that I really liked. So I decided to just palm those slides and really talk about him here. But I want to give him credit. I want to give Lee credit. Are we done? Right? It seems like we have a vector. You have a database that is purpose built for the AI era. Right? You have a database that combines those traditional database features, and you can do vector search over them. You can do all of these. You can do the things that you know and love for AI applications as well as for traditional applications, right? But are we done? And the answer is absolutely no. You have all these different things that are, you have compressed embeddings, you have things like quantization, you have multimodal models, you have sparsity, and the answer is no. We are not done. We're going to continue to improve upon Milvus and by extension Zilliz Cloud, not just in 2024, but in 2025, 2026, all the way, for posterity, right? Some of the things that are coming to open source Milvus: sparse vector support, multi-vector support, and indexes over metadata. So you can actually search over your metadata very, very quickly, rather than doing some simple filtering and then simple brute force filter, and then going on from there. So really, we're going to see this convergence, right, of capabilities. You have vector databases. They're going to have, you're going to be able to do you're going to be able to store traditional data, relational data, or object data, document data in a vector database too. But again, it is not meant for that. And moving forward, because there is so much unstructured data in the world, we want to be vector first. We want to be vector native. I hate using that term, but vector native is really what we want to do and where we want to go.
Vector native, yeah. So basically, this is all focused on making it more performant, more scalable, more distributed, and really making it more worthy of being used in the ML use cases.
Precisely. Yeah, exactly.
Okay.
And one last thing that I want to mention is that a lot of people don't know we actually have an embedded version of Milvus for developers, so that you can just straight up go pip install Milvus and start using it. I'm actually going to show you guys how to do that in a different window here. You just go use it, pip install Milvus, and get up and running with it automatically. Then there's what we call Milvus standalone, which is meant to be a single instance version of Milvus that runs just on one machine. And then we have the granddaddy of them all, Milvus cluster, which is that architecture that I showed earlier. Milvus cluster has a lot of those. It has, for example, a message broker. It uses S3 as the underlying data store, and it has multiple pods. You can distribute multiple pods across multiple machines so that you get the best performance out of your vector database. And I want to talk about Zilliz Cloud as well. There's also different tiers on Zilliz Cloud. Now, there's the starter tier, which is very analogous to the embedded version of Milvus, which we call Milvus Lite. We have a starter tier, which is entirely free. It will be free forever. And you have a standard tier and an enterprise tier as well. This is all just based. This is all specifically for Zilliz Cloud. And you can just go access it at zilliz.com/cloud, right? And I want to talk about very, very briefly before I move to this Jupyter notebook that I have that I want to share with everybody. I want to talk very briefly about the difference between Milvus Lite or embedded Milvus and the starter tier of Zilliz Cloud, right? The free tier of Zilliz Cloud. And really, if you look at it, if you think about it, we've developed Milvus Lite for folks who just want to get up and running, for really hardcore developers who just want to get up and running locally with the vector database and play around with vector search. And then for people who don't want to do that, for people who, let's say, non-data scientists or non-ML engineers who just want to get something up and running, who don't want to worry about managing any of that, that's where I would go with the starter tier. Right? If you're looking to try out some vectors, not on your computer, you want everything to be contained. If you're already using, let's say, the OpenAI API, you're already okay with starting off with having these vectors stored somewhere else. That's when I would get up and running with the starter cluster there. But yeah, like I want to reinforce that even though we have this managed service on Zilliz Cloud, we still are an open source company first, right? And Milvus is going to continue being a core part of our ethos. We're going to continue building out Milvus, building great features into it, and making really the best vector database even better. So any questions? I want to stop there for questions before I move into this.
No, I think we have been asking questions all along. So let's jump into the demo right away.
All right. So let me get into this different tab here. Okay, all right. So I know I only have 8 minutes for this, so I want to leave probably about 2 minutes at the very end for some questions. So I'm going to sort of condense this a little bit. It's a little bit condensed, but I want to talk about customer support. We're going to build a customer support bot very, very easily in here with literally just 3 libraries. The first is LangChain, the second is Milvus, and the third is unstructured. And I talked about how you can just pip install Milvus and get a vector database up and running locally, right? You get the power of a distributed vector database at your fingertips. You can run it inside of a Jupyter notebook, which I'm about to show you guys here, and then start building your queries over it. So I'm actually going to run this just from top to bottom. This actually, a lot of these requirements are already satisfied. So you'll see that there's nothing that I really need to do here. And what I'm going to do is I'm going to prepare some data, right? Oh, what's going on here? What I'm going to do is I'm going to prepare some data. Now, this data is based, there's a nice link to this data. It is some Skyscanner data. And because what I'm building is an automated customer support bot, this customer support bot, I'm going to talk a little bit more in detail about why performance is so important for this particular type of application. You might be thinking, isn't it just retrieval-augmented generation? And yeah, to a certain extent it is, but it's RAG on steroids. And that is why you need a vector database that is very, very performance oriented, that is very performance centric. So what I'm going to do now is I'm going to take a lot of these. I'm going to take questions and answers that are from the Skyscanner website. I'm not really exactly sure where a lot of this came from, but I know that it's based on data from Vanil Navalkov. I apologize if I butchered that name there. But I will take all these questions and I will actually just write them into a list. So I'm going to do all this right here.
So for now, you're just writing the questions in the list.
That's correct.
And that's your data that's going to get stored into the vector database.
Precisely. And I want to show you guys how easy it is to get up and running with Milvus, right? You see there's only 4 cells here. If you ignore the imports, there's literally only 4 lines of code that you can do to get up and running with Milvus. So the first cell here, what I'll do is actually import the quote unquote default server from Milvus. Now, because I've already installed Milvus, I can just, I can just get up and running with it very, very quickly. Now, what this will do is it'll actually, inside of my Jupyter Notebook, it'll start up a mini instance of Milvus, and now I can connect to it, play around with it as I see fit. The second cell here, what I'm going to do is I'm going to create some embeddings, or I'm going to create a way to generate embeddings. And this is going to be done with LangChain, right? Really, really popular out there. I know it's gone through some changes recently for the better. So it's now there are fewer abstractions, and it's actually a little bit easier to use as well. So I'm going to use BG Small 1.5 from, I believe this is actually a Sense Transformers model, even though it's on Hugging Face. And then all of that text up here, all these questions and answered, I'm going to turn them into vectors and store them inside of Milvus. And this is really just the only step that I need to do. And what this will do is, given the vector database that I started up earlier, it will take all of that existing text and it will store it into Milvus. It'll store it into a vector database that is already just running locally inside of this notebook.
And that's the collection name, basically.
Exactly, the collection name. Well, yeah, exactly. So what it'll do is actually create the model name is BG Small, and it'll actually create a default collection inside of Milvus for you to use with LangChain. Now, if you wanted a different collection name, I believe you can just do collection.
I see.
Name.
Oh, there's a default collection name. Got it. Okay, no worries.
Yep. It's just a default collection in that case. But now what I want to do is I'm going to do a quick similarity search, right? Now, using this embedding model, I'm going to search for, it's top case search for flight search. And it's, it says the first document here talks about how you search for flights on Skyscanner, right? Very, very easy. Once I have this data here inside of my vector database, I can now already start using it to, I can just perform the similarity search. Now I can start using it in conjunction with my large language model. And a bit of an aside here, I actually like fully open source everything. Milvus is open source. The embedding model in this case is open source. And I like open source large language models too. I'm not going to run this one here, unfortunately. I apologize to the audience out there, because I just don't have enough compute capacity on this particular laptop. But on my other on my other computer, I run local LLMs all the time. This is an example of how you can run Mistral 7B on, in a Jupyter Notebook. It's also very, very easy. Hugging Face has made it very, very easy, and this is one of the ways that you can do it. Right?
So you have a Mistral model with a Milvus vector database, and then you're doing the flight search based upon the data that you just fed
Exactly. Now, again, I'm not going to run this on this machine, because this machine is a little bit, it doesn't have that much compute power. But I just want to show people, like, this is one of my favorite things to do, which is a fully open source stack. Milvus, Sense Transformers, Hugging Face, and also Mistral AI's Mistral 7B, also based off of Hugging Face.
Is there a way people can access this Jupyter Notebook? Is this part of the samples?
You know what? I will make it. It will be a part of our Milvus Bootcamp. So if you search Milvus Bootcamp on Google, you'll be able to find this. In
Wonderful. Yeah, you might even like to drop a link on the LinkedIn webinar.
Absolutely.
When this goes live.
Absolutely. I'll drop a link. I'll drop a link on the LinkedIn post shortly after this.
Yeah. That'd be fantastic.
Yeah. Now, what we want to do now, and this is the last little bit, again, I sort of condensed this a little bit because I know we're a little bit out of time, a little bit short on time. But what we want to do now is we want to create a conversational agent. Now, a conversational agent, in addition to all of this data up here, all of this, data, all of my organization data, it also needs to store, if I converse with this agent, it also needs to store the past conversations in a vector database as well, because as your context window gets longer and bigger, you don't have the capability to fit all of that into your large language model. I'm going to show you guys, show that to you guys in action.
So I think you're prompting up a question that Dana is bringing up. Hi, Dana. What are the compute requirements to run Milvus stack?
That's a great question. There's not a lot of compute requirements, because at the end of the day, it is just, in the way that I'm using it, is just vector search. So you don't have a specific amount of compute requirements. That's what I love about Milvus, is that depending on the compute that you do have, you can set up your cluster or set up your instance in a way that fits your needs. So you can, even on this Mac, I think it's only got like 16 gigabytes of memory. It's a, it's like a 2019 Mac. I can run Milvus just fine. Right.
Okay, we're just about time, so maybe wrap it up in a minute or so.
Yeah, I'll try to wrap it up in a minute or so. And what I'm doing here is I've built with LangChain this conversational agent. Again, I'll make this code available. I'll share it on LinkedIn, and I can ask it, okay, how does flight search work? And it will actually give me a response based off of that. I can also print and record that response inside of my vector database. Oh, let me see. I've got some sort of error here. Give me one moment. I can print and record that response inside my vector database. You can see that if I ask how does flight search work, it gives me there's some context in there, and it'll give me a response based off of that as well. Flight search and skyscanner works by allowing so on and so forth. And I can ask other questions about it as well. But what is most interesting and why you need a really high performance vector database is you're doing all these insertions as well. In my agent, I can also ask, did I ask about flight search earlier? Yeah. And the answer is yes. Your previous question was how does flight search work? And I can continue to ask complex questions over that as well, right?
Got it.
Now here you have
a code back into the database.
Exactly. And you're doing all these insertions and queries, and as you scale up, now all of a sudden you need hundreds, maybe even thousands of queries per second and insertions per second. That's why you need that architecture that we talked about earlier in the slides.
Wonderful.
Yeah.
Frank, so thank you so much. This is absolutely fantastic. I really enjoyed the conversation. Any last minute tips that you want to share with people? Where should they go? What should they look at? How would they get started?
To get started, you can pip install Milvus. That's one of the easiest ways to get started. But there's also you can, and I'm gonna make it as comment here, zilliz.com/cloud. Right. If you don't want to worry about it, if you don't want a local vector database, just go to Zilliz Cloud.
Awesome. Thank you so much. Thank you so much.
Thank you, Arun.
Thank you so much. Sorry, I was on a mute. So I really enjoyed it. I hope everybody had a lot of fun as well. Thank you, Frank. Bye-bye.
Thank you, Arun. Take care, yeah.
Bye.